Okay, now that you've gotten the redox reaction part down pretty good, now that you understand how to write a balanced redox reaction with the half reactions and what oxidation and reduction are, now we need to go a little further. Because just because we can write this equation like zinc solid plus gold ion turning into gold solid and zinc ion, that does, just because we can write it doesn't mean it's actually going to happen. Because really, if this happened, I could make gold pretty easily, and that would mean that it wouldn't be as expensive as it is. So just because you can write a reaction down doesn't mean that reaction is going to be spontaneous. And so then the question becomes, how do we tell if it's spontaneous or not? Okay, so we're now on the sheet spontaneous reactions. So not all reactions happen spontaneously. Even though we can write them, it doesn't mean they'll take place. So how do we know if it'll occur? So one way we can figure out if it'll occur is to try it experimentally. Take the zinc ion and the gold nitrate, zinc solid and the gold nitrate, and mix them together and see what happens. Now, Mr. Jewett just had shivers down his spine as I'm saying, try it and see what happens. Mix these chemicals together. Probably not always a good plan if you don't have a clue, but it is one way that we could figure it out. So the chart you have here on this page is a chart that was derived from experimentation. So they would have had 4 beakers, one with copper nitrate in it, one with lead nitrate, one with silver nitrate, and one with zinc nitrate. Okay? Actually, they had 4 of each of them. So in one beaker of copper nitrate, they put copper solid, a piece of copper metal. And they put a piece of copper metal in a beaker with the lead nitrate, a piece of copper in the silver nitrate beaker, and in the zinc nitrate beaker. And then they watched them to see what happened. And the only one that reacted was the silver nitrate one. So the copper in the silver nitrate. So then, with 4 new beakers, but the same 4 solutions, they put lead solid in each one of these. And this time, the lead solid reacted with the copper nitrate and with the silver nitrate, but not with the other 2. Then they put silver in another set of 4 beakers with all the same solutions, and this time noticed silver didn't react with anything. And then in the last set of beakers, they put zinc solid, and zinc reacted with the copper nitrate, with the lead nitrate, and with the silver nitrate. So what does all that mean? That means that some of them are spontaneous reactions and some of them are not. So if we know that the nitrates, I hope we all know it now, the nitrates are going to be the spectator ions because they're always the ones just standing there watching. And we know that in this reaction, so like when the, let's say, silver nitrate is reacting with the copper solid, then it's going to be the silver nitrate that's being reduced. It's going to become silver. And the copper is going to become the copper nitrate. It's going to be oxidized. So if the silver is being reduced, then it means it's being an oxidizing agent. So now we can look to see which ones of these are reacting the most. The silver is reacting the most. So we could write the half reaction for silver. It'll be Ag, and it's Ag positive, the ion, aqueous. And it'll be going to silver solid. And if I have to add electrons in, I would add 1 in on this side to balance it. This would be the half reaction of silver that would be taking place in each of these 3 beakers when you put the copper in, when you put the lead in, and when you put the zinc in. Shouldn't be surprising that silver isn't reacting with itself, right? So it's not surprising that silver and silver is doing nothing. Then we could look at the one that reacts the next most. That's the copper. okay, the copper nitrate. So it would be Cu2 positive aqueous going to Cu solid. And we would have to add 2 electrons here. So it's the next one that's reacting the most often. The third one that's reacting the most often would be the lead nitrate. And so in there, it would be Pb, and it's NO, I can't even see, NO2, so it's Pb2 positive, aqueous, going to Pb solid. That means, again, I have to add 2 electrons. And then the one that's reacting the least is the zinc. So set in 2 positive aqueous plus 2 electrons going to set in solid. Okay, and what I've just created by listing them as the ones that are reacting the most to the ones that are reacting the least, what I've just created is a table where over here, this is SOA, the strongest oxidizing agent. And as you go down the table, you get weaker and weaker oxidizing agents. On this side, if we were to go this way, go backwards, the zinc, here, the zinc metal, it's reacting the most. And it is being oxidized, which means it's the strongest reducing agent. Remember, the thing that's oxidized is the reducing agent. The thing that's reduced is the oxidizing agent. So starting down here on this side, this is the SRA, the strongest reducing agent. And as you go up, they get weaker. So we can create a whole table from this of which one's the strongest oxidizing agent, which one's the strongest reducing agent. How does that help us? Well, it helps us because on the back of the sheet, I give you what's called the spontaneity rule. And what it says is, if the oxidizing agent is above the reducing agent in this chart, then the reaction will be spontaneous. If the reducing agent is above the oxidizing agent, then the reaction will be non-spontaneous. So if we look over here and I said, okay, I'm going to mix silver ion, so silver nitrate with lead, will this be spontaneous? Well, this is the oxidizing agent, this is the reducing agent, and the oxidizing is above the reducing, so yes, this should be spontaneous. And look, there was a check mark there, which was telling us it did happen. What if I said, okay, let's mix zinc nitrate with copper solid? This time, the reducing agent is above the oxidizing agent. Spontaneity rule says this should be non-spontaneous. When I look at zinc nitrate and copper, it didn't react. It was non-spontaneous. So we can create a whole chart, and if we had more entities, we could get more in here. Well, speaking of more entities, we can do that. See, there's this lab exercise, 12A and 12B, that I have somewhere in all of these papers, and you have somewhere in all of your papers. Okay? Whoop, that's not it. All right, and so what I would like you to do is to do this lab exercise, and you're going to create from the exercise, from this chart, you're going to create another little table, just like what we did there a few minutes ago. Okay, so it's exactly the same, only it's going to have different entities on it. Okay, so you're going to create another chart just like this one. That's lab exercise 12A. And then I gave you a third one down here, okay? And you're going to create a third chart, just like this guy, with the items off the third table. So then you're going to have 3 tables like this. And then what you need to do, and it tells you in the directions when you read it, it says put the 3 tables together. Now, I don't mean to scare you, but you're going to have to use some logic for that. So see if you can put the 3 tables together.